Alright, Miss Dean, this is what we were kind of struggling with in class today, so I just want to kind of talk to you about this. Right here, what this represents is this is the reflection of this triangle, right? Specifically over the line x equals 1, composed with the reflection over the line x equals negative 2, right? And then here this is going to be of, just we'll say of the triangle. Okay? So what that means is first I'm going to reflect this over the line x equals negative 2. So here's the line x equals negative 2, and I flipped it over that. Then I'm going to flip it over the line x equals 1. So here's the line x equals 1. I now flip that image over that. Now take a look. If we take a look here, the distance between these two lines is 3 units, right? From negative 2 to 1. But what happened to the actual shape itself? Well, the shape itself, we can see that this point moved all the way over here, which is how far? 1, 2, 3, 4, 5, 6 units. So here, whatever that horizontal distance between the lines is, we're going to go twice as far and when we translate. Okay? Here's what you have to remember. Because this is both x equals, the translation is only going to occur with the x coordinate. So I can already fill in that that y is going to be 0. And then here, I'm going to do 1 minus negative 2, and then I'm going to double it. 1 minus negative 2 minus a negative becomes plus a positive. 1 plus 2 is 3. And then if I double it, I get 6. So you can see that is the 6-unit translation that we saw over to the right. Okay? Now, had we done this backwards, it would have been negative 6, and the object would have ended up all the way over here. Okay? So let's go and take a quick look at an example. So here's an example where triangle ABC has these coordinates, and I will find the coordinates of this composition of that triangle. Okay? First thing I'm going to do is just rewrite this as a translation rule, right? So here I know it's going to become the translation by a vector. These are both y values, so I know that x is going to be 0. Now I'll go ahead and do negative 1 minus 5 and double it. Negative 1 minus 5 is negative 6 times 2 is negative 12. So doing these two reflections will also just move it down 12 units. So triangle A, B, C. Okay. Now what I can do here is simply subtract this from each of the y values and get my coordinates for A prime, B prime, and C prime. Note for the homework you don't have to do this extra step, but here we've got negative 3, 4, so that'll become negative 3, negative 8. We've got B is negative 2, negative 5, that'll become negative 2, negative 17. And then C prime is 1, 2, that'll become 1, comma, negative 10. Alright, pretty straightforward, no problem. So here's the first problem you have on your homework. Alright, number 9 says R of M composed with R of y-axis, and it just wants to know what would the translation rule be. Well, they're trying to trick you here. They tell you in the directions that M is actually x equals 5, so I'm trying to replace that with x equals 5. I know for a fact that the y-axis is just the line x equals 0. Now I'm ready to rewrite this as a translation. So this will be a translation, right? Since those are both x equals, I know that the y value is not going to change, that'll be 0. And now I'll go ahead and do my little side math where I do 5 minus 0, and then I double it. 5 minus 0 is 5, times 2 is 10. So this number right here is going to be 10, and this will be my composition of translations. Okay? Email me if you have any more questions. Hopefully that clarified it for you. Take care.